Good morning, and let's see this problem. It's very nice problem and beautifully crafted based on just summation of vectors. Find the smallest positive real number r with the following property. For every choice of 2023 unit vectors b1 to b2023 in a plane, a point P can be found in the plane such that for each subset S of 2023 numbers, the sum lies inside the disk given as follows. So before I go further, it's better if we can appreciate the problem with a smaller data points. Instead of 2023 vector, let's say if we have only two vectors. So consider a subset S of just 1 to 2. Let's duplicate the problem only for 2. So now the question will be read as a smallest positive real R with the property for every choice of two vectors. For every choice of vectors v1 and v2, a point P can be chosen in R2, which means in 2D plane, such that a subset of 1 and 2, the sum b1 plus b2 lies inside a disk mod x minus p is less than equal to 1. Right? So what does it mean? So let's say we have b1 and b2 as unit vector. If I treat b1 as this one, so we can have combination a subset containing only b1, a subset containing only b2, a subset containing linear combination of b1 and b2. So it can have any other orientation. So I'm just giving one possible example. Let's say b1 is over here and b2 is exactly assisting each other. Similarly, we can have b1 and b2 which is killing each other, or we can have in an empty set, right? So this is an example when the subset S1 I have taken only 0.1, this subset is 2, we have subset S1 and 2. Similarly, this corresponds to subset 1 2, this corresponds to subset 1 2, and this corresponds to again subset 5. So we have all possible for subset. Now we need to find the minimum R such that there is always a disk which contains this vector. So in the first case, we might be tempted to get the value of R which contains this is R equal to 1. But can we do it is lesser than that? So clearly R equal to 1 is one of the value which is going to contain this. Right? But here probably we can do R. Suppose the point P is exactly the midpoint of origin and head of B1, then we can have this disk as well. Because the choice of point P is arbitrary, right? For every choice of unit vectors, a point P can be found. So definitely in this case, if I take, instead of point P is origin in this case, if I take the midpoint, we'll have a next circle. So I can get an R of half, which will assist our condition. Here v1 and v2 will cancel, so clearly any disk will work. So here the radius will be 0, and that will work because we have just single point. So radius 0 will work, right? Here again in the similar way I can take r equal to half works. Now if I have b1 and b2, clearly we'll have their linear combination somewhere here. So again, if I take a disk having length diameter as the length of b1 plus b2, that will definitely work. So r is, let's say, called rd, but still I can make half of this diameter and we can make a circle out of it, right? In empty set any radius will work, so because any value will definitely work here, so that will not give any point. In b1 plus b2, again if I take a circle with center p is origin 0 vector, then definitely it is going to work, but we can go lesser than that, and of course more greater value is definitely working. So but in this case we can go lesser than that, and let's say if we have b1 and b2 which is assisting each other, we can clearly find the midpoint of this b1 and b2 because this length is 2. So if I take midpoint as b and radius r equals 1 is going to work. Now for all orientation of b1 and b2, what I can tell is the maximum among this, because we need the minimum value of r such that any combination of this vector b1 and b2 is contained in this. And the minimum value of r cannot be half, because if it is half, then we can't have a disk of radius half which contains when two vectors are in same direction, right? Because this diagram will not be possible, because here the minimum radius is going to be 1. So we have to take maximum among all the possibilities. So half, 0 and 1 and so on, because these are itself their minimum. So maximum of minimum among all situations is going to be 1 here. Okay. So if the question would have been exactly for 2 points b1 and b2, the answer is 1, right? What about it is for 3 points? And remember, mod x minus p less than equal to r represents mod x minus p less than equal to r represents a disk having center p and radius r. So all point inside the disk is represented by a variable point x over here, right? X minus p distance will be less than equal to r. So for 3 points, similarly, we can see the situations, the configuration. If we have v1, v2 and v3 assisting each other, under this condition I'm going to have a disk centered at exactly midpoint of origin in v3 under this configuration, and the radius that I'm going to have is 3/2. Because for any other configuration, definitely radius will be lesser. Let's say if they are not along the same line, so instead b1 and b2 is on the same line and b3 is orientated differently. So clearly now their summation by vector law of addition will be this length, right? And this length is less than 3. This is definitely less than or equal to 3. In the extreme case, it will be equality when all the 3 points head are coinciding, they are calling here, right? So for this length to be lesser than 3, for this one to be lesser than 3, definitely we'll have a disk centered again at the midpoint of the resultant vectors with radius is r mean, which is in this case lesser than 3. But that will be valid only for this configuration, because let's say if someone takes b1 and b2 and it exactly cancel each other and b3 is over here, so in this case, since they kill each other, so we'll have radius half, because that disk is definitely going to like hold this combination of vector under these situations when b1 plus b2 is 0. But we want for all configurations. So for all configuration, this is extreme case, and hence again the max value of all r means, okay, the set containing r means will be going to be 3/2. So in the similar way, you can generalize for 2023 and the configuration at which minimum r will be achieved when all these 23 vectors b1, b2, b3 till 2023 they are lying collinear. Okay, so they are assisting each other, and we'll have a point P which is actually midpoint of 0 and the head of B 2023. We have this great disk which contains this, and in this case R value I'm going to get is 2023/2. Now can it be lesser than that? Clearly not, because someone can tell what if R orientation is in this direction. It doesn't matter, because now for this choice of B1 till B 2023, again we will have point P over here, so that is arbitrarily chosen, and the minimum radius is still 2023/2. In case if you take any other combination, the radius will definitely be lesser than that, because the resultant vectors will be b1 plus b2. The magnitude will definitely be less than equal to 2 from triangle inequality. If you want to algebraically show this result, because this is from the field by generalization, so algebraically we can also show. Let's say if I consider a point P given by average of, so means of all those point Vi, where I is running from 1 to 2023. So this is algebraic way of doing this. And if S is the subset of, let's say 1, 2, 3 till 2023. So what I can say is the distance between sigma Vi, where I belonging to S, minus P is definitely half times of distance between sigma vi, I belonging to S, minus sigma vi, I does not belongs to X. This is quite clear because suppose if I take a subset, let's say S equals a subset S1 is 1, 2, 3. So under that condition, what I'll write? I will write B1 plus B2 plus B3 minus that point, which is B1 plus B2 till B2023 by 2. And this simply evaluates to, you can see it evaluates to B1 plus, because 2 times this minus with this will be B1 plus B2 plus B3 minus the leftover B4 till 2023 over 2. And this is nothing but half times B1 plus B2 plus B3 by 2 minus leftover B2023 by 2. And this is precisely all B's when I belongs to S, and this is I does not belongs to S, right? So that is what I have written over here. And now from triangle inequality, this will be lesser than equal to half times sigma Vi plus sigma minus Bi, right? Sum of two sides of triangle is greater than third side. And since the magnitude of all these vectors is 1, so that simply goes to 1 and this goes to 1. So it's half times of I belongs to, this is I belonging to S and it is I not belonging to S. So the number of I definitely in both of them. If you have 3 elements here, we'll have 2022 elements here. If I have k elements here, we have 2023 minus k elements of here. So their sum is 2023. So in this case, you can clearly see the maximum possible value that we are getting by the triangle inequality. So sum lies within the disk centered at P with radius. So center is P with radius 2023 by 2. So that will hold all the points here. Okay. So on the other hand, if you can see if all B1, B2 and B2023 are equal, that's what I was telling under this configuration. So if all of them are coinciding with each other, B1, B2, B2 till B2023, then their summation will definitely span a length of 2023. So under this condition, the sums correspond to S equal to 5 will be a radius 0, and sum corresponds to S equals entire set 1 till 2023 will corresponding to radius 2023 by 2. So since they are at a distance S equal to 5 and S equal to S at a distance of 2023 apart, so clearly existence of disk with 2023 by 2 is an optimal value of the R. Right? So I hope you enjoyed this problem, and this was very basic problem motivated by fundamental rules of vector addition, but the wording and the beauty of the problem lies in the structure and the way it was defined. And definitely algebraically I have shown now you can't achieve any value lower than 2023 by 2. So in general, if the question would have been B of 2026, the answer R minimum will be 1013. Okay. One special note about this is, what if I have 3 points in a plane? Basically this is known as geometric median, and the idea of the problem was motivated from there. So let's say if I ask you in 1D, so just in R, if all these numbers A1, A2 till AN belongs to R to the power, means all these are real numbers. And if I ask you to minimize the distance mod x minus x1 mod x minus x2 mod x minus a. So clearly we have n points over here on number line a1, a2 till n. And you know the value of x4 is this distance will minimize, and it can be proved. It's again a very beautiful problem, is when x is median of all these data set a1 to a. Right? And it might not be unique, so sometimes it will be multiple answers. If I ask you the another question, if x minus ai whole square sigma I equal to 1 to n has to be minimum, then the value of x you can differentiate and easily you can say x is going to be the mean, x bar. So this is beautiful concept between median and mean, which basically is very effective in industrial purpose also, because to minimize the distance. Now in 2D version things becomes more interesting. So what if I take points, let's say P1, P2 in 2D in R2, and I ask you for 2 points, let's say P1 and P2. I want the third point such that this plus this distance will be minimum. So here it's quite easy and obvious for 2 points. If I'm anywhere along this line, definitely the sum of distance will be fixed and the minimum distance will be P1 minus P2. So that is obvious. What if it is 3 point? And that is interesting case, and it's known as Fermat's point. So let's say we have 3 cities P1, P2, P3. You want a location such that from there this sum of distance is minimum. So now we want P minus Pi sigma I equal to 1, 2, 3 to be minimized. Now a common sense tells like most of you will feel it will be centroid, but that's clearly wrong because we can do better than centroid. The best way to appreciate this problem is you can imagine a pulley with same mass m hanged over this 3 points. So imagine like the entire system is kept on a horizontal table, okay, and these are a spring, and you keep like massless pulley hanged over these 3 points P1, P2, P3 and let them relax, let them fall. So the moment it will fall, it will attain a stable configuration, and the most stable configuration will be the one with minimum potential energy, right? This you know from basic physics, because if potential energy is minimum, it will attain the stable configuration. So this is a case for U minimum, stable equilibrium condition. For minimum potential energy, the length of the spring that is available on the table will be minimum, and since it is in a state of equilibrium, we know the resultant force on the point P, if you'll see from all the 3 directions, must be equal because it's the same string. So T tension is same. So by Lami's theorem, it must be at an angle of 2 pi by 3. Right, so that shows like P is a point which will definitely make an angle of 120 degree each. This definitely I am telling for a triangular case, for the case where none of the angle is more than 180 degree. More than 90 degree, more like for acute angle triangle. If it is more than 90 degree, then definitely if we'll again repeat this physical experiment, you will get to know like this point will be one of the vertices. Okay, and that is a special point known as Fermat's points. Now clearly this is not within your JEE syllabus, but interesting to know. You can do the same thing for 4 points. So let's say if you have P1, P2, P3 and P4, again you can make physics, use physics to hang a spring over all this. And here interestingly what you are going to see is you will get the minimum point is point of intersection of diagonal, which is again not centroid. And that's easy to prove because for let's say if you have any other points, clearly this sum of distance P2P plus P4P will get an equal to P2P4. Similarly, P1P plus P3P is greater than equal to P1P3. So if I'll add this equation, the minimum value is going to be P1P3 plus P2P4. And that will be achieved at the point of intersection of diagonal. So PD, point where diagonal intersect, is the point that is going to be minimum. Now this basic physics principle can be made more stronger. Like instead of just summation with weightage 1, I could have asked you, what about I times of Pi minus Pi minimum? This summation I want to minimize, where I equals 1 to, let's say n. Right? So still you can give philosophically from physics principle. Now the force will be in the ratio 1:2:3. And the same thing can be asked even in 1D, where now you have mode concept also. So how many times number will be repeated? Okay, so based on these premises, this question was created, and that was the motivation of taking P as the center of mass for all these points, or I can tell like the centroid for all these 2023 points. In the very first go, I have chosen P to be that. Okay, because for any value of P, it can be shown that distance will always be exceeding that. Okay, and here minimum will be achieved at exactly the sum of all vectors 2023 by 2. So I hope it clears your doubt regarding these questions and also gives you exposure of how to think under different conditions from the basic. The point was to experiment with the smaller values, and that gives a hint how to approach for larger values. Thank you. Have a good day. Please do like and subscribe for more